In this video, you will learn GAMS in 10 minutes. I will show you how to implement a mathematical model in GAMS. At the end of the video, I will give you a mathematical model example, and you will be able to implement it on GAMS yourself. In this video, I assume that you know what mathematical models are. Here's the equations of a mathematical model which I want to implement in GAMS. As you know, mathematical models includes sets, parameters, variables, and equations. So here are the sets of this mathematical model, I, j, and k. And now you can see the parameters. It has 5 parameters and 2 decision variables. So the first thing we should do is to write down these 4 parts of a mathematical model: sets, parameters, variables, and equations. First, we need to fill in the sets section. As you can see, letter I indicates index of factories. Here I assume that we have 2 factories, factory number 1 and number 2. So you can see that I put 1 and 2 in front of I between 2 slashes and separated them by comma. Next index is letter J, which indicates customers. Assume that we have 3 customers: customer 1, customer 2, and customer 3. So how should we write it here? Exactly like before. We put them between 2 slashes and separate them by comma. Or we can write it like this, as I wrote in front of ka. There is no difference. We must type a semicolon at the end of the sets section. Now let's fill in the parameters section. Our first parameter is D with the index of J, which represents demand of customers. If J is equal to 1, D represents demand of customer 1. And D with the index of 2 represents demand of customer 2. And with the index of 3 represents demand of customer number 3. This is how we set this parameter in GAMS. We write demand of customer 1 in front of 1, demand of customer 2 in front of 2, and demand of customer 3 in front of 3. Next parameters are VF with the index of I and VD with the index of K. We add these inputs like parameter D. As you can see, our last 2 parameters have 2 indexes. If our parameters have more than 1 index, we can't just write them like before. We should add them in a different way with the code table. For example, this is how we write parameter CD with the index of I and K. Remember, in GAMS, indexes must be between 2 parentheses. This is how we write tables. Index I or first index represents rows and second index represents columns. For example, here this number indicates the price of goods that distributor 3 received from factory 1. So we do the same for the last parameter. For each parameter that has more than 1 index, we should write a new table. Next, we should write variables. The first variable we add is the variable of objective function, which here I indicated as z. We have 2 other variables, qd and qc, which are integers. So I write integer variables and add qd and qc. Next part is the equations. In this part, first we write the name of each line of equation. For example, here the name obj represents the objective function, and the name co1 represents constraint number 1, and so on. Then after a semicolon, we write the codes. First we write the name of the objective function, which is obj, then we add two dots, and then we start to write the code of the objective function. In GAMS, here's how we show equal sign. And in order to indicate the sigma notation, we use the code sum. Here you can see that summation is on the index I and index k. In order to show them in GAMS, we must put them between two parentheses and add comma between them. After we typed our indexes, we add comma and start to write our variables. Remember that you should type semicolon at the end of each equation. For each constraint, we show these sets here in the parentheses in front of the constraint's name. So let's write our first constraint. If you remember, we put the indexes of the sigma notation of the objective function between two parentheses. However, here in the first constraint, we shouldn't put the index between two parentheses because the sigma notation has just one index. So remember, if we had more than one sigma notations, we should put the indexes between two parentheses. But if we had just one sigma notation, we shouldn't use parentheses. So let's write the rest of the codes. They're easy like before. Write semicolon at the end of each equations. Remember that. Let's write the second constraint. Yeah, it is easy. It's pretty much like the first constraint. And now it's time to write the third constraint. The third constraint has less than or equal symbol, so we should indicate it in a different way. This is how we write it. So to sum up, these are the three symbols: greater or equal, less or equal, and equal. So let's write the fourth constraint. It is pretty much similar to the third constraint. Yes, and remember to put the semicolon at the end of it. So until now, we just wanted to add our input data. But now we want to tell the software to solve our model. How should we do this? We should type these three codes: model, solve, and display. These codes will help us to solve the model. In front of model, we should type the name of our code. For example, I call it supply chain. Then we must write the name of our equations between two slashes and separate them by comma. Or instead of this, because we use all of our equations, we can use the code all. In the next line in front of solve, we must write this code. First, we write the name of the code again, which is supply chain. Then we write using, and then we write MIP, which means mixed integer programming. Now I know that our model is integer programming, but this will work as well. And it is completely okay to write MIP. Then, because our model is the minimization of the objective function, we write down min and z. In the displayed part, we should write the name of the variables that we want them to be displayed. We must type .l at the end of each variable. Here you can add 3 option codes which make the code better and reduce the errors. These 3 option codes are not essential or necessary. In order to run the code, we should click here. And let's click on yes. You can see that it gives us an invisible answer. Well, we can fix it by changing the amount of some parameters. So I change this amount and run it again. As you can see, this time it gave us an optimal solution. And you can find our outputs here in display section. I've included an article in the description that presents a mathematical model which you can implement in GAMS. If you have any questions, feel free to leave a comment or send me an email. Additionally, I've provided some information about other types of variables in the description. Thank you for watching.